How's it going, everybody? I'm JJ Holton, a senior engineer out of Colorado Springs for the commercial AV department. And my notes are over here. So I joined HiPoCON. It's been almost 2 years. I've been working in the industry since I was about 13 years old. So started out kind of as a tool boy or whatnot for my father, and would go up to Cheyenne Mountain Zoo and hand him screwdrivers and help him bury wires, things like that. It was really cool. Eventually, I found that I was kind of good at math, so I decided to indulge in some electrical engineering at the University of Colorado in Boulder. Got that degree. Didn't really feel like moving to California and getting a job out in Silicon Valley, so I went right back to work with my dad. And we just continued to build systems up and down the Front Range of Colorado and some other places too. And then about 2 years ago, HiPoCON Networks acquired Holton Audio Video Applications, and here I am. So first we'll start off by talking about some video teleconferencing. I'll take kind of a little bit of a back step. This presentation is going to be kind of a little bit about everything AV. You know, it's going to have, we'll talk about some QSYS and video teleconferencing. We'll talk about intercoms for schools, things like that, along with maybe talk about how to design or pick the right displays basically for a room, and talk about some video walls and things like that. So with teleconferencing, what we've been finding obviously since COVID is everyone uses it. I know at HiPoCON, we're scattered all around the country. So almost every day we're on Teams calls in order to collaborate and to basically optimize systems for, you know, all of you guys, our clients. So we'll jump right into QSYS. QSYS is really all over the place. And sorry, I have notes, which I wanted to pull up here, so a little scattered, so apologize for that. So, you know, QSYS is in, you know, the corporate world, the hospitality world, transportation. In the corporate world, you know, it's conference rooms, it's boardrooms, it's divisible rooms, all the way to little huddle spaces. But, you know, you can expand this. It's so expandable. You can, you know, do command and control operational rooms. You can do courtrooms. You know, more in the hospitality world, you can do zoned paging and background music. It's a really cool platform that is just really versatile for whatever industry you're in. It also applies to education, such as lecture halls, conference rooms for schools. Again, it's all over the map and what you can do with an awesome platform like QSYS. Kind of diving a little deeper into that, a system core in QSYS is really the engine that drives everything for the platform. So it's your DSP on the audio side. It's your video engine, allows you to control your PTZ cameras for a conference room. It obviously, through your switch and through PoE, you can have your little control panel, one in the front of the room, one in the back of the room, wherever you need it to be. It's an all-in-one sort of platform that allows you to do as little or as much as you really need for a given space. This kind of dives into a little bit more of kind of the ecosystem capabilities like I was kind of speaking about. It's all through a network switch. AV over IP is kind of the name of the game these days, right? So through that network switch, you have your control panel that's pushing PoE right over a category cable. All the way to third-party devices where you can have, you know, a Shure or an Audio-Technica beamforming ceiling array microphone mounted to your ceiling that would pick up all of you guys all simultaneously in this room for conferencing purposes, things along those lines. You also integrate your amplifier, so you still might need to pull some speaker wire if you're, doing some low Z systems, some high Z systems. But the point is that Q-SYS is just so adaptable and allows you to do really whatever you're trying to do for the given room that you're designing with. I'm going to jump into a case study. This is for Stutzman County Law Enforcement Center that was up in North Dakota. We built this earlier this year, and this was a really, really cool project. It was 3 rooms, kind of like the rooms that we're in here, that have these dividing walls. What the customer was asking for is when you open and close these dividing walls, for it to trigger a given scenario for the conference room setup so that you do not have to go through and change your whole configuration every time you open or close kind of a sliding door. So per each of these rooms, we had 4 ceiling speakers that were kind of wide dispersion. Were about 110 degrees horizontal, which really gave even coverage for all 3 of these individual rooms. So that's 12 total speakers. We also incorporated 2 beamforming ceiling array microphones, one for the front of the room, one for the back of the room, to ensure even pickup, basically, for remote participation on conference calls and things like that, for any of these scenarios, whether the rooms are open or closed. So when you were to open up a given door, those beamforming ceiling array microphones in the other room would participate with the beamforming ceiling array microphones that are in your current room. Same thing goes with the speakers, same thing goes with the touch panels. And that also applies to how we did the displays. So this was kind of a conferencing setup or whatnot. So we had dual 75-inch displays. The left or the right display didn't really matter because you could change that around in the programming. But for say, the left display would be your far end participant, and then you would have your content on the right display. As soon as you open up that door, all of that goes to the room that's adjacent. And then we would automate based off of what the customer desired for a given camera to be the primary camera for that given room, depending on the configuration. This also incorporated auto switching when it came to input connectivity, where people could use the little dongle that everyone talks about, right? Where you plug in your USB-C unit and wirelessly transmit your content basically to that left display. Or if you wanted to hardwire it like we are here, you could do that as well. It tends to be a little bit more reliable sometimes still in 2025 to hardwire your systems. So this system was relatively complex. This kind of shows that. This is the Q-SYS designer file from a very broad standpoint that we're going to step through kind of component by component. But this slide really is just to illustrate the complexity of how the system was. So this first one kind of shows all that automation where you're using snapshots basically to control how these rooms and how these reed switches that are getting triggered by when you open and close the wall basically combine the microphones, combine the speakers, or separate them, chooses your camera for you, and duplicates your displays across the given scenario. This is kind of a cool, this is another layer kind of how that UCI worked, where essentially we built in a maintenance page that only the IT director of this space could get into, had his own little pin pad or whatnot. So say he needed a different kind of configuration, he could go in and override the automation in order to get the desired outcome for that meeting. This is an example of the complexity of how the encoders and decoders worked. So what we were using was this Crestron AirPlay, and we had to feed each of those outputs of that AirPlay basically into a given encoder that lived in our equipment rack in the back of the room. This is one of the parts of how we built in the automation, essentially, of how the auto switching worked. This is kind of showing the output side of that, where, again, it's utilizing selectors into visionary solution decoders, which are a very cost-effective encoder and decoder solution that integrates very seamlessly with QSYS. This is kind of showing us a little bit about the input. Well, the gain structure, kind of how the mixing worked, the delays that we had to kind of incorporate for the conferencing side, things kind of along those lines. And it was the beginning part of how we had to integrate the echo cancellation. Now, oftentimes, we don't like to use AEC twice, right? If you're using Teams, AEC is already integrated into Teams, and it works really darn well. In this given scenario, though, because of the room combining, we had to build our own kind of AEC structure of how this works. And it actually got kind of weird, to be honest. So in that lower corner, it kind of shows how those AEC references for a given room all feed into a mixer. So it's your decoder references times 2, along with the speakerphone, which is your far end participant, the reference signal for that. All feed into that given room's mixer. Then there's a second mixer that combines that reference signal with the other reference signals that then goes into a third mixer that combines all of those reference signals and is controlled by a snapshot that mutes and unmutes basically the proper reference signals based off of the automation. So it was kind of tricky to figure that out, to be honest. This is kind of an example of how our UCI turned out, where when you open up, or on your touch panel, this is kind of the first page that you get to see. So, you know, you have some presets for your camera, whatnot. You can power cycle your displays if the automation wasn't working properly, etc. And then we dive into some of the maintenance stuff that only the special people, you know, get to kind of have access to, things along those lines. This kind of shows how you can adjust, mute, unmute some of these beamforming ceiling array microphones. So say the governor was in this room and it was all opened up, wide open. You might not want a bunch of audience participation to the far end participants, right? So you might choose for that given scenario to come in and just leave one microphone open, you know. This didn't incorporate any sort of sound reinforcement or anything. This was all strictly for video conferencing purposes. So none of these little lapel microphones that tend to be problematic sometimes. You also say that reed switch that does the automation happened to break or something like that. Somebody bumped it with a ladder. You know, stuff happens, right? This gives you a way to override that and, you know, choose your room configuration physically from a given touch panel. So from there, sorry, I've kind of been winging this and I haven't been using my notes, but I'm going to start doing that a little bit better, I think, here. I wanted to talk to you guys about how we kind of pick displays for a given room. So the way I always think of it is you start by asking your client or asking yourself, what am I going to be displaying on a given display? How many displays do I need? Things like that. But say you're a utility company and you're looking at spreadsheets constantly. Well, that's a reason to pick a larger display, right? Versus if you're always doing video teleconferencing or you're showing a lot of videos, things like that. But a good rule of thumb that I like to use is that if you look at 3 times the diagonal of a given display, so say your room is what, I'll pick a round number, only 10 feet long, so 120 inches. Well, what's a third of that? That would be 40 inches. That's kind of the realm of like a huddle space that would only be, you know, 10 feet from your furthest participant basically to those displays. Now the other consideration is you don't want to sit too close to a display. I'm not sure if any of you have ever tried that where, you're sitting in front of your 70-inch flat screen at home and you're, 3 feet away from it and you're doing this and all of a sudden, you're getting kind of nauseous and things like that. So it's always really important, I feel like, to consider all these aspects when, you're designing your given space. That even includes your ambient light. Well, and how often are you going to be using this display? Is it a command and control scenario? There's just so many variables that play into designing your space to optimize, your employees or your users' efficiency of that space. And, when you balance all these things out, all of a sudden it starts to become clear. Well, maybe I should use projection still, even though that's kind of dying out. There is still purposes for larger spaces like where we're at right now. Of course, now you can get a 90-inch display from Costco, right, and slap it on the wall. And that, sometimes, that's a brighter solution. You don't have all the maintenance of a projector. You don't have to clean filters, change out light bulbs if you're using lamp-based projection, etc. So what I'm getting at is there's just so many variables that play into why somebody like me has a job, right? I wanted to just touch on one of our awesome vendors that is out on the floor right now, Daktronic. They are a South Dakota-based company. Right here, of course, my notes don't even say it. Is it in Billings? Is that Brookings? Yeah. Yeah, so Daktronic is an amazing company that's really just boomed in the last few years, and our guy Alex out there on the floor can answer a ton of questions about how to implement, on either a tight budget or say you've got a really cool large-scale project. It's just a really, really great company, US-based, TAA compliant. If you're a government agency, that's usually pretty darn important. But their stuff really just is robust and has so many use cases. I know that they actually incorporated the message boards all up and down the highways of South Dakota and redid that whole system or whatnot on the highways. This is an example of a video wall that we installed down in Pueblo, Colorado at the Real-Time Crime Center. This video wall was approximately 12 feet by 7 feet tall and is primarily used to display in real time the cameras all around Pueblo, where they could drag and drop the cameras in there. So when you do the math on that real quick, right, there's 64 cameras on that image there. So each of those images is already, about 1.5 feet wide by just under 1 foot tall. So you can actually see 64 cameras from, the 10, 15 feet away and actually see what's going on those cameras. So that was the purpose of building a high-resolution 4K 60-hertz video wall for the applications such as the Pueblo Real-Time Crime Center. These real-time crime centers just are going to continue to boom and are really becoming a valuable piece to our society and how we can combat and alleviate stresses basically on our law enforcement, etc. So yeah, this video wall was composed of 36 discrete panels. Our modules with 4 panels per each of these modules. So what is that math? 144 total panels that are approximately, about 9 inches by 6 inches. And we had to, use magnets to basically place these things. And it was surprising how fast and efficient it actually went once you started placing these panels on these modules, and how awesome it turned out, like you saw in that previous photo. I think that picture that lizard was taken from, probably 15 feet away, something like that. This kind of goes into how the wiring played out with these panels, where you have these PCR units on the top that kind of drive how the connectivity flow works with a video wall from Daktronics. You see that orange line, that's the fiber pole that basically talks to, these discrete PCRs. And again, if you want to talk more kind of about these Daktronic video walls, Alex Barrett, our rep out there on the floor, he has a live demo of a 3x3 0.9 millimeter lift case display that is about 6 feet by 3.5 feet out there. It's a great showcase of how these video walls can look. The brightness factor is very impressive, things along those lines. So from there, I know my topic kind of scattered all over the place, but I wanted to touch on some school intercoms. I do know that there's several people here in the audience that are K through 12 IT administrators, etc. So as we know, these loudspeaking intercoms are so darn important these days. Communication is so darn important these days with education. Along with, there's 1,000 other use cases for loudspeaking intercoms, government buildings, hospitals, even your warehouse, things like that, where there's lift forks everywhere, and sometimes it's pretty darn important to be able to make a loud page, basically, that gets over that noise floor, right? So the history of loudspeaking intercoms, it used to all be over this 4-wire solution, right? And you would have 2 pairs that basically go down to a call switch that would allow you to basically initiate a call and have 2-way communication back to a master station. That would be, in your office, things kind of along those lines. A lot of these intercoms are still half duplex, although I know Axis, for instance, just came out with their own version of a loudspeaking intercom that is full duplex. But really modern intercoms now don't operate on these 4-wire solutions. It is so important that we keep our infrastructure up to date. If you look up above a given drop ceiling or whatnot, you'll see cat cabling just all over the place, right? We have network drops all over. Well, that's how a lot of these paging systems are operating now. They're all IP-based as well. But kind of diving into intercom some more, it is just so important because you can do your bell schedules. You can integrate other third-party devices for emergency response purposes. You can integrate little duress buttons underneath the counter for, your school admin people or whatnot to do a lockdown just at a push of a button if they see something going wrong there at the office. And I realize that, a lot of these schools, you've got walkie-talkies and you've got your phone system, but it's also important to still have that redundant communication aspect where, say, your walkie-talkies aren't working properly, or one of them dies, or your phone system fails, something along those lines. It's always good to have a good backup, because when there is a problem, well, we all know it's a pretty dang big problem. So this is kind of a slide describing more so the capabilities of modern loudspeaking intercoms. Again, that they're IP-based usually now. You can usually set up your zones and everything. So say you're a K through 12 school, a relatively small school, something like that. You can break out all these zones so that you can do a zone page just to the elementary side, a zone page just to the middle school side. You can have discrete bell systems that operate just for your elementary side, just the high school side. So they've really come a long way in how you, the adaptability, the amount of different things you can do with your intercom. Bogan E7000 intercoms. Again, you can tie a lot of these intercoms directly into your phone system so that you can do loud pages or whatnot throughout your building from a teacher's workstation even. Again, use pre-recorded announcements and triggers and things like that to trigger lockdowns. You can do visual indicators through these I/O units that will light up the strobe in your gymnasium so that people that might have hearing difficulties know that there's a page going on. You can do scrolling displays, just the adaptability and the amount of different things you can do with these systems now is just really abundant. This is something I'm going to just skip over because that's kind of a sore subject right now. This is, again, just showing some more of specifically the Bogan E7000 capabilities and how it all operates as an IP system over your WAN or LAN. Wanted to jump into, again, another Bogan E7000 case study here that we're building down in Fort Carson in Colorado Springs. This integrates override systems like we've been talking about for, duress signals. Also, if somebody pulls the fire alarm, it'll use that loudspeaking intercom, the speakers and everything will repeat your fire alarm signals. You also can use these cool little gateways to drive things like your auditorium or your gymnasium sound systems to where it'll override the content basically of if somebody's using a microphone or has background music for while kids are running around in circles and things like that. And we'll go ahead and drop that signal and allow your page to go over that. Same thing with classroom voice lift systems. It can override those. A lot of these things, you can also integrate redundancy. You can have an auto failover system controller. So say that you do have component failures in your primary unit. Immediately, in the blink of a second, it'll switch over to your auto failover so that you have zero downtime while you send off the other one for repairs or get your technician in to come and troubleshoot it. This is kind of an example of, again, it's still the same case study at Abrams, but you don't always have to have IP speakers, basically. So a lot of these speakers run on a 70-volt line or a 25-volt line. It's called a high impedance zone, where you can daisy chain multiple speakers and run right down the corridor in an efficient fashion. Obviously, that doesn't allow you to break out those speakers into independent zones or anything like that. But that's kind of where the hybrid aspect of a lot of these intercom systems still plays a part. This is another one of those that's just showing kind of the complexity of how zone paging can work, where each of those discrete things on the left side, or your guys' right side, are all separate 70-volt zones, essentially. So one of those might be the exterior zone to your fields. One might be the front horns, basically, of your school that are servicing the parking lot, along with discrete hallways that might be, your middle school area, etc. This also incorporates second admin display stations, where you could land your admin display station as a backup in the security office and have your primary be your, main desk lady, something along those lines. It also breaks out and has overrides for your gym sound system, your music platform, and your common sound system. And then each of these classrooms has a voice lift system. This is kind of depicts that, where each classroom has a given call switch, a voice lift system, voice lift speakers, and then an IP speaker. And this is kind of showing you how that override kind of takes place, where if somebody hits that call switch, that digital call switch, it will go ahead and shunt off and mute basically the microphone of the voice lift system that's being used as sound reinforcement by your teacher, or mute the content basically that's going on your displays or projector for that given room to allow that override to take place for an emergency kind of situation.